we all know that we have three versions of HTTP, right? 1.1, HTTP 2, and HTTP 3. I'm going to skip the historical part of it, but for now, let's just consider that for the 80% of websites, HTTP 1.1 is still the most active and most used protocol. Especially if you think that those stats only analyze the out-facing part of HTTP, so only the one that is client-server. But if you think about internally, so you have a reverse proxy, 99% of the time the reverse proxy is talking to Node or to whatever via HTTP 1.1. And not even by using keep alive, which is a very stupid thing, but that's another topic. Where are we in Node? In Node, we used to have Node HTTP underscore parser up to 2019. It was one of the oldest dependency in Node, inspired by Ruby Mongrel and Nginx. And it worked just fine. It was capable of delivering 1.5 million requests per second back then. It was an amazing software. The only problem is that it had a very complex architecture, was very hard to maintain, nearly impossible to maintain, and it was completely written in C++, which of course makes the learning curve very steep. I mean, it's not the friendliest language to use. That was the situation up to 2019, which means Node 12. Back then, what happened is that Fedor Indutny wrote LL-HTTP, which is our current parser. This new current parser is just an amazing piece of art because it just works very fine. We doubled our performances, and we have an easier to manage software because LL-HTTP is based on LL-parse, which is a state machine parser, capable of generating a parser for any text-based language. It just has one little problem. It's written to transpile TypeScript to C. That's how it works. And it is a mess because LL-HTTP has no documentation whatsoever, nothing at all. So every time you have to work into that, is basically crossing fingers and hoping that everything will just work. That's an issue, because when I started working on LL-HTTP a couple of years ago, with some security fixes, it was a nightmare. Because especially when you switch to the test suite was also amazing. It has a very comprehensive test suite for analyzing HTTP. This test suite was inherited by HTTP Parser, but it was written and purported to transpile Markdown to C. So LL-HTTP, I mean, Fedor is a genius, but he's a crazy genius. One of those crazy geniuses. It was just amazing. It works just fine, but he left not a single line of documentation. So it's nearly impossible now to maintain that. That's insane. If you look at my latest PR, I say, I hope it works, but I actually have no real idea why and how it works. And the impact, because anytime I add a new state in the huge state machine, I have no idea what's going to happen, if I'm going to introduce any side effect. If you look at the original, there is on YouTube online, the original presentation by Fedor about LL-HTTP. On a slide, it showed the state machine generated by LL-parse for HTTP. It's like this size image, full of states. You cannot even read the labels because they are too small. And when it's transpiled, it's actually automatically generated huge switch statement in C, and I'm talking about 1,000 or something different states there, which is impossible to debug. That brings to the simple point is that how do we fix this situation? Now, the architecture of LL-HTTP is so peculiar that it's pretty much impossible to fix it. And it also has one problem that is becoming, over time, a huge problem, but it's also something that is relevant to Node.js in general. Due to this thing, my first talk that I ever delivered was about how I fixed the slow loris bug in Node. And I did it in NodeConf last October, right? And I keep doing this talk because they ask him for this talk in many conferences. There is just one big problem. Every time I find myself saying the honest truth, which is, if you want to feel really protected by this kind of DDoS attacks or something like that, don't put Node directly in contact to the client. Which, as a Node contributor, is weird, because you look at people saying, oh, you brag that you're Node contributor, you brag that Node is cool, and then you basically tell me, do not use Node. Makes no sense. And why do we have this problem? Because we inherited by early stage of Node one approach that I think we should completely give up, which is the HTTP parser is lenient, not by default, but it can be easily made lenient, which means accept all the horrible stuff that non-compliant clients was to do. And for each of those that I accept one leniency rule, I potentially introduce a lot of vulnerabilities. And it's something we should stop doing. Even worse, but this is not, it's just that LL parse is pretty old. LL HTTP is currently parsing RFC 7230, which is now also obsoleted. The new standard for HTTP is 9110. If we start supporting that in LLHTTP, we're potentially introducing incompatibilities because the two standards might be in conflict. So what do we do? I have a solution in mind that I still want to implement and see where it leads me. Or if I also join this thing to what we spoke today about having a standard library, modular library, an initiative similar to Undici, I'm thinking about writing a new parser for HTTP. This time, not in C, not in JavaScript, not in TypeScript. I'm leaning towards Rust. Rust is low level enough to be a good language for performance, but high level enough to not scary people if they want to contribute. I also plan to have this parser trying to transpile to Rust itself, optimize Rust, but still readable by a human. And eventually, after this stage, generate standard static libraries that can be linked against Node like we do today. Is a new approach that I want to explore. I haven't written a single line of code yet. I've seen that I can easily generate a standard library and C headers to include into Node, so this is doable. Or eventually we could ditch the C++ and we directly transpile to WebAssembly if it's faster. That's also something, for instance, for Undici or for even Node itself. And also in this one, I want to keep the goods of LLHTTP. So I will keep the state machine architecture, I will keep the test suite, but I want to do something different. Better transpilation, and also strict by default, no leniency allowed at the beginning. If people really want that thing, eventually later we can reintroduce leniency. But for now, we are strict, we follow the standard by the rule. The latest standard, so 9110, we ditched the 2616, the 7230, we just support the latest one. And this might be the first step to a new HTTP stack in Node, because we might have unified architecture with 1, 2, and 3, this parser, and eventually a new server, like happened to Undici, a new completely modern server for the HTTP stack. That's it. You saved a lot of slides.
This is very cool. So,
yeah. Sorry, because I run out of voice.
there we go. All right. So the first question that comes to mind is the LL parse, which is the state machine generator that you would pass things into. Is that piece of the puzzle fine to keep around? Could we know?
The thing is that if you analyze LLHTTP source code, you can kind of read the TypeScript code and follow the states from state A to state B, because the interface is pretty clear. Now, the thing is that for me, it was impossible to relate how a state is mapped to the C version. And that's LL parse, which has zero documentation.
I see. So you're talking about just a ground up rewrite.
Yeah.
Now, you mentioned keeping this. I mean, this. I've thought about this too. I've busted open the 1910 or 9110, whatever that RFC is. It is, yeah, very complex. Have we considered doing something like the Node performance talk? Yagis had like brought on like a professor of computer science, I believe, to help him rewrite the Ada parser, the URL parser, which he titled Ada, and it uses like fascinating parsing algorithm technology to like get that. Could we consider essentially consulting someone smarter than ourselves to be like,
absolutely,
state machine parsing's fast? Is there a better algorithm that exists nowadays? Can we leverage that parsing algorithm instead?
Yes, absolutely, we could. But I guess I haven't checked how Ada is written, but I guess it has the similar problem that we have in HTTP. Is that one very good thing about LLHTTP is that it uses pretty much close to zero extra memory. Basically, you give the input. It does not need to copy any data of the input. You just analyze byte by byte, I mean character by character. And except for maintaining state of the current state, so very close to zero memory overhead, it does not involve creating structure, does not hold anything. And that's something I would like to keep because it's very performant, because we don't do anything with the data.
Yeah, I would say that this is academically, this is just talking about parser technologies.
Yeah,
there are just go-to parsing algorithms and parsing formats that are either zero memory overhead or otherwise, and it's like you pick one or the other.
The thing is that in that particular part of Node, we care about performance because people want to have a fast. I mean, people are asking for more performance, and I think they're very spoiled nowadays because there used to be a Ruby on Rails times, right? I love Ruby on Rails, but it was much slower. When I discovered Node, they say, "Oh, this is much faster," and then people say, "Oh, we want to be faster." Oh, come on. Come on, please. Somebody you have to stop asking, right?
Yeah.
But I mean, I see your point, Ethan. If we have people that can help me design the fastest or the smallest algorithm, I would love to have them on board. But for now, to be honest, at the beginning, what I'm focused on right now is to see if I want to have a really little proof of concept to see if I can reproduce this thing, and then eventually fine-tune performance and so forth. But at least I want to see if it is doable to rewrite a similar architecture in Rust with all the specs that I told you about.
So you mentioned this being the foundation for a new HTTP stack.
Yep.
We discussed this, not this part of it, but the higher level stuff in the web server frameworks team, which I think maybe at some point we can go through some of the issues, and I'll link you some. The conversations did stop a little bit because of the HTTP 3 stuff. So what I'm interested to hear from you is, how do you see the unification effort going on top of this new foundation? Like, do you have a technical design in mind?
No, not at the moment. Okay. Because first of all, in the slides I promised James that we're going to review the quick PR before we get to HTTP 4, because it's something we have to do at some point. The thing is that the problem is that those stacks are very complex because HTTP 1 was text only. I'm not sure which part of HTTP 2 is binary, and HTTP even worse. So there might be no way to unify that architecture. But at least, let's say, we can come up with a common API, or at least common API eventually, or interfaces, even though the implementation then must be different because, I mean, it's very hard to think that we can get the same architecture from TCP and UDP, for instance. I mean, speedy versus quick or so forth. But at least we start thinking about HTTP is a gigantic common module that has three probably different versions, rather than what we have today, which we have HTTP, HTTP2, and then even a third PR, which makes things too much fragmented.
Yeah, and so that was one of the problems we were really trying to tackle with that discussion, is especially with the fact that the 2 and 3 implementations are just so not widely deployed. We were trying to figure out what is the right line for the API that we expose, and what we landed on was we need 2 layers of API. A very low level one, which is probably 3 separate still, HTTP 1, 2, and 3, and a higher level one, which is what we actually have users directly using. And the users might be frameworks, but ideally, and this is what the real thing we were going for, is ideally the frameworks are there to add structure, but the actual API that Node core exposes is usable for the basic use case, right?
Yeah.
So that would be like, it correctly sets the content length.
Yes.
Right? Which is like
For
a
instance.
framework thing
For instance.
today, right?
Yeah.
Not a Node core thing. And like the idea would be a college student who's learning Node is probably not going to understand how to set the content length header properly.
Mm-hmm.
And today, the only answer to them is go use Express or Fastify or
Yeah.
whatever. What would be nice would be if we had those things starting to move more toward the core model. So I'm interested in what you think about that, and if you think that aligns with your.
If you think about that, if you remember, we're talking about the parser. I mentioned RFC 9110, right? If you look at the title of the RFC, it says HTTP semantics. So does not allow for the version, because the version apparently is outside of that thing, because even on the HTTP different version, they say the bottom layer is handled by 3 different versions, because there is pipelining, there is multiplexing, there is other things. And on top, there is semantics about methods, headers, content length, chunk encoding, and so forth. So we have to. I completely agree that we have to think on different layers.
Yeah, and it's that's what I remember reading. I remember reading I just pulled it up. 1910 is semantics. 9110 is semantics. 9111 is caching. 9112 is 1.1.
Yep.
9113 is 2. 9114 is 3.
Yes.
And then and then beyond that, it's all of the other ones, all of the older specs.
Yes.
There's like 5861, 8246. These are all like different other HTTP
Yeah.
pieces.
So
but it's like, as you were saying, if we do 9110 as that like core piece, then you can implement the other ones on top of it,
exactly.
which is a solution to what I think the old web frameworks group was discussing. Is we want to if we want a new HTTP stack in core, I think we got to revisit these standards and specifications and rebuild some things
and follow by the rule, because the problem is that we've been allowing clients and server to do nasty things when they speak to Node. We stop doing that, because every time we allow for a rule, we mess up another rule for sure.
Mm-hmm. Okay, and so that was my follow-up question then. If we like this direction, and you're talking about doing it similar to Indici, my question is, how do we see those other layers? Do we think we need to do them all in the same way? Like we pull them all out into separate repos, we get them lined up, finalize them, make them good, and then we vendor them in? And if so, then do we vendor them into, and this is a big discussion we had at that group, is like, well, we already have HTTP, HTTPS, HTTP2, HTTP3, what do we call it, right?
I have no answer, because the thing is that before coming here today, my intention was I write another parser, I replace the dependency in an LHTTP, done. So it was not meant to be a standard library. But then we spoke this morning on the next 10 and say, oh, you know what, that might be a good first or second module that is close to core, supported by core, but not part of core, similar to what Undici Fetches already is. So I kind of changed my direction after this morning talk, and we have to see, even with that effort, where we are heading. I have no answer at the moment, because if we chose not to do that effort anymore, I will go back to the original idea that, as we did for HTTP parser, we replace the dependency. But at the moment, I have no answer, because when that initiative leads us, we also lead basically this initiative.
Yeah, I think it's probably not smart to tie them too tightly together, because if you make great progress, then like that should just land, right?
Yeah.
If possible. But I think at least keeping in mind that at some point we want to put some effort into making a better end user HTTP experience directly in Node Core is at least just like something to keep in the back of your head is probably...
My opinion is that with that, in regard to that initiative, is that since we know we're usually very conservative and very grandfathering for the users, those modules are never going to disappear, and we're just going to be a new namespace of modules that are eventually encouraged, but the other one are still supported, because we have to support people up to 10 years from now and so forth.
But I guess you could vendor everything behind a node, new HTTP one. That is not currently used, if we want to move it.
I mean, did you remember the HTTP parser to LHTTP transition? What happened?
Yeah.
The thing is that it was first experimental, then it was enabled by default, and eventually actually HTTP Parser is still there in the source code. You can eventually still use it after 12, 14, 16, 18, 20. After 5 major versions, still there.
So 7 years.
Discouraged at all. So that makes no sense.
Yes, true, but it would be like everything, like the testing runner and everything. Like it could allow people to build on top of it if they want it.
Yes.
If no one and if people want to continue to use some framework implementation or stuff like that, they can still use it. We won't be breaking anything, but it would be an easy way to provide new stuff to people without including breaking change, and you can use it. It's a specific namespace stuff inside.
Yes, absolutely.
I was just thinking, like, if we could, like, build a HTTP parser as like just a parser module on its own, expose that like totally separately from like the actual serving of things, and like we kind of already have like the lower level facilities that like you could spin up a TCP server and then like do the manual thing if you wanted to, but we could then like use that as like stepping stone to add more things. Like I mentioned in like the next 10 thing earlier, like the service worker fetch event, like a lot of like Cloudflare and all these like serverless platform things are doing that like fetch event spec thing. You just have like add event listener fetch, and like behavior like you're a service worker. Like if we could introduce that as like a new HTTP API that uses that instead in like the future, and just like introduce all these new pieces on top of that, but not need like the whole thing at once.
The thing is that if we can, one thing that I'm stealthy omitting from this is that if we manage to do this for HTTP, we can potentially do it for many other parts of the code. Of course, let's forget it. And the thing is that the only reason why I want to tag this to Node Core a lot is because at the moment the HTTP server processes the data in the C++ layer before even getting to the JavaScript layer, which means that for this reason, since I don't have access to native bindings like we were talking this morning, it's hard for me to be performant if I have to do from C++ to JavaScript to eventually to C++ or web app. So I have a double jump of the data that I have to find good ways to avoid. But that's another topic. That's at least for... That I have to, I have to speak. I have to speak with him about this. That's the biggest issue here.
I definitely.
To me, I think like we should try to avoid actually doing anything in C++ unless like we need actual system resources.
Yeah.
This is not a thing where system resources are needed. Like we don't have the data in the process.
Yes.
I would say definitely stay focused on that like single piece, and like it's awesome ideas of what we can do next and all that, but like we can talk about those things as much as we want until we build that first piece, until you re-implement that parser. Nothing else can come. So it's one of those like just do that, and then let's solve the next problem, and let's like cross those bridges when we get to them. We can think about them, we can talk about them, but also like let's get that, like let's ship that change. So is your ask, are you looking for other people to help or get involved? Are you leading this? Are you?
I was not specifically asking for from people. So I'm mostly starting now that as a spike, consider as a spike or POC, whatever you want to name it. If people want to contribute, are more welcome to do so. So if anybody is more than welcome to contact me, and we can see what we can do. Absolutely.
Awesome.
Question, comments, whatever. Jean?
Do we want to do something with a web framework team group, something to have a follow-up? Oh, it's like, I don't really care about this one, but...
Well, so it doesn't, but it is still, I don't know if it's chartered. It is open with everything. So if you needed a host group to host the work, like there's some structure from Node around like what a team can own, and then the team can like graduate to a if you need the actual like ownership, right? The like structures are there to then graduate that to a working group, which we decided not to do because we didn't need it at the time, but it's there.
Tooling's another option too. Not quite.
Well,
Actually, this also brings to one thing. In Node, we are for some reason lacking. I mean, it's not because I work on that module, but we can probably all agree that HTTP 1, 2, or 3, whatever, I don't care about the version, is one, if not the most used module in HTTP, and there is no working group for that. It's so weird.
well, so the Web Server Frameworks charter like covers,
Everything.
I think, all of this. Like, I think so. If you wanted that to be it, like we can just fix it to make it more clearly. We could even change the name probably pretty easily.
I mean, you don't like clients. Why just web servers?
Well, specifically at the time, the discussion and why it started was actually at one of these. I like went to Matteo and I was like, Express, Fastify has like so much overlap, and now I'm actually on the team that maintains Restify. So like I'm like, yeah. So I was like, we have so much duplication of things. There's no good way for us to really like collaborate, and I think we all agree that stuff needs to be moved. The core APIs need to be better. And so it spun out, and we specifically chose Web Server Frameworks because it was supposed to be a collaboration between the maintainers of the existing Web Server Frameworks. Yeah. What came out very early was that the clients have a stake in this. So that is how the fetch implementation discussion got started. So I think we probably have just like a slight miss when we started it, we didn't realize quite that. So I think if we changed it to be HTTP working group or whatever we wanted to call it, I think that would be probably a good.
Well, it works fine to
thing,
me. Absolutely fine. Yeah. Yeah.
We can choose.
Okay. So when to be honest, personally speaking, I have limited time to explore these things due to for working reason, but I will try to explore as soon as possible. As soon as I have a little news, I will ping you all, and eventually you can start working on as a working group.
And one nice cool thing is that I think that there's a team on GitHub set up for it, so you can like mention the whole team, and it pings everybody. So that would be a nice way to just leverage that.
Cool.
Again, that's where the team setup. It's just like the structure that helps it make it easier for you to reach the right people.
Cool.
It doesn't need to be meaningfully changing what you're working on it or how you're.
No, yeah. I see what you mean.
Yeah.
Works fine.